Hello, good morning and good afternoon. Thank you so much for joining us today. Today we have a very special webinar indeed, and this is the first webinar series that is going to the 10th Balkans Energy Summit, taking place, of course, on the 19th to the 20th of May, 2026 in Athens, Greece. Of course, the 10th Balkans Anniversary edition of the summit is proudly endorsed by the Hellenic Ministry of Environment and Energy, and the Energy Regulatory Commission of the Republic of North Macedonia, and the Albanian Energy Regulatory Authority. As we prepare for this milestone gathering in Athens, today's discussion sets for the tone of one of the most critical region and conversations: how Southeast Europe can scale decarbonization in a practical kind of an investable and industrial viable way across the Balkans. We are witnessing industrial carbon exposure and growing urgency to deploy hydrogen solutions beyond theory. And the question is no longer whether hydrogen will play a role. The real question is, how do we actually deploy it in a way that is decentralized, cost-effective, and immediately applicable to the Southeast European markets? And actually, this brings us to today's topic: scaling decarbonization in Southeast Europe, methanol reforming, hydrogen and carbon markets in practice. And to guide us through this discussion, it is my pleasure to welcome Adrià Sancho Fibla, the Business Development Manager EMEA at the methanol-reformer. Adrià, welcome, and thank you so much for joining us today.
Hello, Karam. Good morning, and good morning, everybody, and a pleasure to be here.
Thank you so much, Adrià. There is a lot of questions regarding methanol. It's a quite interesting kind of a topic, especially in Southeast Europe. If you don't mind, I would like you to introduce yourself, of course, methanol reforming as well. Where is the company based? What kind of projects does this company lead as well?
Perfect. So yeah, first of all, thank you very much for the opportunity to come participate in the summit, and of course to be here today in the webinar. It's a pleasure, and appreciate a lot to you, Karam, and to AN and VR. So, well, as you say, so I'm representing here, I'm the Business Development Manager from methanol-reformer. So I'm the expert in the fields or in the maritime industry and the applications of this technology. So we are a company based in Barcelona, so we are located in Spain. We are working around the world, so that's not a big issue. So for the moment, as I said, no, we are located here in Spain, but with projects around the world. We consider us a startup, but even we have already 3 years of experience in the market. We always say that our technology, the good thing is that we have the real projects of hydrogen, because sometimes when we talk or when we listen about the hydrogen projects or these decarbonization projects are mostly in the PowerPoint. So what we like to say is like, look, we have already the real technology that it works. We are working, as I said, in all the continents. And that's the most important point, that it's a reality that we can start to develop and it's not need to be developed in 2030s, 2035, And of course, as I said, so I'm the responsible in this Balkans area. So that's why it's so interesting for me to know more, because at the end, I will learn a lot and to can explain to you what we can offer and what we can do with this reforming of the methanol process.
Mm-hmm. Thank you so much, Adrià. Of course, methanol-reformer is a great company located in Spain. Of course, decarbonization on hydrogen is very important everywhere. Of course, some places, some regions, it's more important than other regions, but the majority really needs methanol, hydrogen, decarbonization. These kind of a valuable topic is very important to every single region and country as well. So now I want to start with the first, let's say, kind of a basic introduction to the methanol environment. What do you think, what is the methanol reforming and how does it work as a hydrogen production technology? We have hydrogen, green hydrogen, decarbonization, but I wanted to ask, what is actually methanol reforming? How does it work? Why is it cost effective? Take us deep to a way that, let's say, you can summarize it in like one sentence that everyone can understand. What is a methanol reforming? Why is it better? Why is it cost effective? Why companies should, let's say, get it more, do more case studies on it, etc.
Yeah, So interesting. And yeah, if you allow me, I will start that the why the methanol. So we are considering methanol like a carrier of this hydrogen. No, so as you said, and of course with this all this process about the hydrogen as the new fuel, because it's of course has a lot of good things. No, really good power of density, and we don't have this. We can say it's like decarbonizated and sustainable fuel. No, so at the end, that's the main reason. But the problems that we find something is that about the cost and the inefficiency in these logistics of hydrogen. So that's why we believe that it's in its incipient market, methanol help us as a carrier of this hydrogen. So the main question here is, yes, we use this methanol because we believe that it's the most efficient or the easier way to have this hydrogen at this moment. The good thing is that with our technology, we are, of course, the name of our company is so I always say that it's so easy to understand what we do. So yes, we are reforming the methanol. So it's a thermochemical process that we convert what we are able to produce from our machines, a mix of denized water and methanol into hydrogen. No, so the good thing, and that's why we believe that is a good start for this hydrogen production, is because we can produce this hydrogen on site, on demand, and even off grid. No, so it helps on about these logistics, as I said, because sometimes the problem that we have, even you have an electrolyzer and it works, is that it's so difficult to transport this hydrogen. No, methanol is liquid at room temperature, so at the end it's so easy. We have experience because it's a common alcohol, so with a long experience in market, different industries, and what allow us is this high hydrogen density. Because in the molecule we have this hydrogen included, and allow us to can produce this hydrogen from a just to have this tank with methanol and water. We need to produce this hydrogen, just to understand a little bit, the size is like 62% of methanol and 38% of denized water. So with this mix, we are able to supply this pure hydrogen to works after if we need electricity with a fuel cell, or if we need this hydrogen for the industry or for refuel a hydrogen bus or truck. So without any problem with a compressor, we are able to do that. No. So basically, and returning to the question, the way that we produce this is a catalytic with a catalytic reactor. So this is we can say easy process. It's nothing we can say new. Where we have our patent is in the purifying system. No, with our purifiers, we allow to have this pure hydrogen. And the good thing is that this hydrogen that is not pure enough, and with the rest of the exhaust, we take profit and we do to be efficient to use we use this energy in the production of this hydrogen again. So at the end, if we compare, for example, with other technologies, so that's the main reason and how it works, not this hydrogen production and what it allows to us.
100%. No, thank you so much, Adrià. I mean, here we have mentioned a lot of things about why is it cost efficient, why is it kind of the best thing that companies can ever get as well. You mentioned something, a word that is really good, that it's a carrier that is like transforming its liquid based as well. So this is actually the same question as, let's say, the second question. So I want to let's say move on to the second question, of course, just so I can make it match. But what actually differentiates methanol reforming from other hydrogen pathways in terms of cost, flexibility, and scalability as well? Because of course you have mentioned that it's a carrier, it's cost efficient, it's liquid transfer, which liquid transfer is very good for logistics companies to move with as well. But I think there's a lot of points that I took note of: 60 to methanol, 38 water based. So can you walk us through what is the differentiation from other hydrogen pathways? Mm-hmm.
First of all, I always like to say, or to start in this kind of question, like we believe in all the technologies who can allow us to have hydrogen. So it means that when I talk about the methanol, it doesn't mean I don't want to say or don't want to seem that I would say the methanol is the best and the rest are not. No, of course, no. We believe, and unfortunately, we don't have enough methanol in the world to produce all the energy that we need. So at the end, this mix of technologies and this mix of different ways to have this hydrogen will help us in this change, for example, from the fossil fuels or something like. So at the end, it's important. I always like to say that that we believe in that kind of different solutions to have that. But after that, as I said, what we say or what we believe is that this incipient moment, as I commented in the first question, methanol help us, no? As you said, for example, for us, what we consider at this moment is like, okay, we have different solutions to have this hydrogen. First of all, for example, the electrolyzer to have this hydrogen compressed, no? So at the end, it's really good. We can consider even the ammonia, no? So it's another gas that they allow us to have this hydrogen. And at the end, the methanol, no? So is where we started. And again, here the most important point on that is, as we say, no, is we can consider the methanol the most cheap way to have this hydrogen, even safer, no, because at the end, for example, ammonia is poisonous, so at the end it can have a lot of problems in this gas, no. So methanol, of course, you can't drink and you can't burn, no. So it's not, we can say it's not water, but at the end we have experience with a lot of alcohol, so that's not more different than this. And the difference is here, no? As you said, we are liquid. We help in this storage, in this carrying of this fuel. And at the end is the most important point in this logistics. We can say it's that in these challenges that we have this, or to consider the prices, it consider it really, really cheap instead of these other options to have this hydrogen. No, for example, just to have an idea about the capex too. No, we need less capex than our competitors in this case. For example, electrolyzers. No, again, if electrolyzer works, because unfortunately the experience sometimes in the electrolyzers. And we need electrolyzers. Again, I don't want to seem that I say that these electrolyzers are not good. No, we believe in electrolyzers, and we need to produce the green methanol electrolyzers. No, but at the end, unfortunately, the experience that we have in Europe are that not all electrolyzers are working or can work 24/7. So our solution is a compact solution. It's just imagine 2 meters per 1 meter and 130 solution. So really compact, useful, and it's easier to do and to produce this hydrogen. No? So at the end, here can be this, no, and the capex, of course, they said if you compare are lower. No, so we don't need any operator, for example, in this production. So you can control remotely the units that you have, for example, from Greece in Albania or from Croatia to Bulgaria. So at the end, it's really useful and so easy to compare, and that's give you the chance to can produce 24/7 remotely. So you can control these units that you have in another part without be there. So it's a really good difference, between the production on site that you can have with this electrolyzer. Another important point, and I always like to say about the difference, is about the high pressure. No, that sometimes seems that it's maybe can be not an important point, but it's an important point and safety reasons too. No, so of course when you have to scale this high pressure, you need more space, you need more capex, not to do that. So at the end is where we are working on that side, no? That okay, you can produce this hydrogen without any problem at low pressure, and it allows you to, after, of course, if you need a compressor, again, to put that in high pressure, it's no problem. But at the end, you can transport even at low pressure if it's needed. No, of course, it's not nothing about another important point too is, and you say, no, is about the OPEX, no, and here is where even we can consider the stability and the independence, for example, like the grid, no, because sometimes the same again with electrolyzers, we will depend always about the prices of the electricity. Of course, can be sustainable, like sun or wind, but at the end, we are always dependent of that, and again, about the water, no? So sometimes it's okay. I know that in Balkans there are a lot of countries with a lot of water, but sometimes, or maybe for example in Greece, we can have the same situation like in Spain. No, that depends on the year. The water can be not a resource that you have a lot of that, so you can have to consider that sometimes I like to say that it's sustainable, a solution that will use water, no, instead of the people. So at the end, it's interesting too. So in this kind of things, of course, what we can offer is this stability and the prices, because methanol at the end is really stable in the prices. We have every time more disponibility, availability of this methanol. Of course, the gray one is not a problem because we have for all the industries, and we have after that, of course, and where we are more focused is in this green methanol. No? So this production of this green methanol that we can consider more expensive at this moment, but every time the prices are decreasing and we can be so competitive, no? So here our OPEX always will depend on that prices. Just to imagine and just to have like an average prices, with the gray methanol, we have the prices between 400, 500 euros per ton. So it allows us to produce hydrogen at 4 or 5 euros per kilo, so really competitive. And with the green one, we can consider that they're between the prices between 8, 10 kilos per hour, per kilo. So it's really, really competitive, this 8, 10 euros per kilo. With the green methanol in the price is at 1,000 euros per ton, so approximately. Another difference, no, and what is important points too is like, of course, if in this process that we can have is about the no production of NOx, SOx, or PMs, no, in these pollutants, we can say particles. So it helps us a lot in these new regulations, new requirements or policies from the UE, no, so in this production. So we don't have these emissions, so it helps a lot instead of the diesel, no. And even we are using the gray methanol, so it's more available. In this transition, we are emitting 30% less emissions than the diesel, no? So even we use the green one, we can say that we start in this decarbonization mode. After that, and the other part of the questions about this flexibility or scalable solutions. So the good thing about the flexibility is what they say, that with our solution, you can produce on site, on demand, and on grid. So it means that you are totally free to produce where you really need this hydrogen. No, of course, we have to consider always that we need this fuel, so we need always this methanol and water. But after that, the good thing is that you can produce on with these conditions. No? So give you a lot of flexibility in that solution. And about the scalable, yes. So we are moving between our solution with one of the reformers. We are producing between 150 to 150 kilowatts per hour. So of course, if we are considering a project like 2 megawatts, 3 megawatts, we have the solutions in container solution with the fuel cells. So we are able to can give a turnkey solution for customers depending on the requirements. If we need 2 containers, if we need to work, for example, we have projects in Saudi Arabia, so in really hot conditions, or even in Norway, so with cold conditions. So at the end, we adapt, and the good thing is that our technology is good in that sense to can adapt on that requirements. Of course, we at this moment, if you say no, we have a project for 10 megawatts or 20 megawatts. I like to be always realistic, no, and maybe the quantity of reformer that you will need will be too much, no. So of course, if you have space, will be not a problem. But sometimes in our territory in Europe, it's so complicated to have that kind of space, no. So at the end, we need to always try to adapt on that solution. But the good thing is that, as I said, no, we are totally scalable and competitive in prices. Mm-hmm. And well, I think that it's all that I can say about these differences and the scalable solution that we can offer.
Thank you so much, Adrià. Actually, very interesting indeed. I took a lot of notes, but this is, this is the only thing that is really, really special about methanol. As you said, it's actually safe. Of course, there's high pressure, there's low pressure, there's storage. But I like how the first thing you said, regarding the hydrogen, there's a lot of types of hydrogen, there's a lot of carbon. The carbon markets has a lot of things as well. But, you have really differentiated between methanol and other types of hydrogen. As you said, it's more safe. It requires, low pressure, of course, more storage. And you gave us the last thing, which is your project in Saudi Arabia. Of course, there's a lot of hot conditions in Saudi Arabia and in the Gulf region. But this is why, a lot of companies needs to do their research, what works for them the most. Of course, methanol is cost effective, but sometimes if you require a high storage, a specific kind of a condition to have methanol or other kind of carbons or hydrogen. But this is actually very interesting indeed. In terms of decentralization, how can decentralized hydrogen production support industrial decarbonization in Southeast Europe? You have mentioned Saudi Arabia, you have mentioned, of course, some projects, but in Southeast Europe and the Balkans area, how can we see this hydrogen production going on, especially to support industrial decarbonization?
Yeah, no, yes, that's so important question, because of course I think that it and what I say, no, that I think that in south east or in the Balkans region, it has sense, no? Because unfortunately, we have weak or unstable grid. So at the end, or even it's so difficult, no, to access this grid. It's in around the Europe, we have the same problem, no? But of course, I think in this area, no, so these industries that can need this grid. And we have a lot of challenges in electrification and sustainable or decarbonization solutions, no? Because most of them, for example, with the EU requirements, no, for the new countries that maybe will join to UE, but of course the countries that are in UE. So in this case, our solution can adapt really well because, for example, when you have to wait maybe 2 years to can connect to the grid, or you have to pay a big amount because at the end it's not cheap to can connect to the grid. So what we can offer is like, okay, we have a solution, as I said, in between 2 to 6 months to can produce your own electricity. Even of course, if you are waiting these 2 years, you can start now in this production. So at the end, it allows you to be totally independent or free of this production. No, so it's a good point to start. Like, okay, we can be this. Of course, after that, we have a mobile solution too. We can put all in a container, and we are able to move from one side, and when you have the grid, to the other point or to the other company. So at the end, the good thing is that it's total adaptable on the project, as I say, and that's the most important point. No, like okay, we can adapt easy and fast to that requirement. So maybe in this industry or these infrastructures that you are having now, it demands a lot of electricity, no? So even, and I always like to say, no, it's not just in the Balkans area. In Spain, we had a blackout a few months ago, no? So the grid is not stable, and sometimes in this economy, we can't lose 1 day or 2 days, no, waiting to that, or the projects that you can develop, no, or these tourism that now are raising up a lot in this area. So at the end, is a really good demand of grid. So we can start with that, no? And after that, related to the hydrogen, more than electricity too, because sometimes it's so, if you allow me to say it, it's like even funny, no, that when you listen that now we will have pipelines of hydrogen from Spain or from the south of Europe and to the north. So for the moment, I think that is science fiction. So we have to wait on that. So this hydrogen availability is so limited, and the production, about the production, no, or the pipeline. Again, if you have an electrolyzer near you, is perfect. But of these projects that maybe you will have as a cities or this hydrogen production for the buses, for these vehicles, you will have problems to have this hydrogen. No, so what we do is like this fast implementation of the solution. After that, of course, we can adapt. The same with the new regulations for the electricity, for example, for the grid, for the service stations. No, the service stations in the UE, they require the new policies, like you need 400 kilowatts each 60 kilometers. So even in West Europe, we don't have, so the same in East, no? So, okay, we can start with this solution. And after that, maybe I can consider if I keep our solution, or, okay, I remove and I put in the other service station that I can need, no? So at the end, is that helps us on that points of the Europe requirements about, for example, ETS, the carbon pricing tool, or no? And another important point that you have here in Southeast Europe, of course, maybe Greece and all the, well, Adriatic Sea, no, or even the Black Sea too, is about the maritime sectors. We are having now with the new regulations on the ports and on vessels, so we can adapt. We have the marinization certification too, so we can adapt to put on board the vessel or in the ports to work, as I say, no, in this decrease these CO2 emissions with no emissions of NOx, SOx, or PMs. So at the end, it helps us a lot to can introduce our solutions in that kind of projects, no? So I think that here it's so interesting that how we can help this area on that side, no? And even the most important too, and I didn't comment before, sorry, because is the efficiency. So we have a really high efficiency in the production of this hydrogen, is around 82. But we can consider, because in this area you have a really cold countries, we can say, so we can help because we can take profit of our heating, the heat that we use in our processes to production. So we can take this heat for putting the heating for the offices, for the buildings that we have near our solution, and take profit about all these residues, no, to can increase this efficiency. But at the end, there are some projects that I like to say that even a lot of, for example, projects related to agriculture with the CO2. Of course, as I said, we want to use the green methanol, but in any case, we will have emissions of CO2. But this CO2, for example, we are working now in a project with Netherlands to take this CO2 to put in the greenhouses, no, for the agriculture. So at the end, you have a lot of countries that the agriculture is so high, no, the activity of the agriculture. So we can do the same, no. We can have the electricity, we can have the CO2, we can have the heating. So at the end, the good thing is that I always like to say that we can adapt really well, and you see that one project bring you another one, no? And again, returning to the main point is, I think that the good thing is this decentralized hydrogen production that we can offer. It's good because we are attacking now. We are now focused in these targets, like for example, the remote areas that you are working. You are increasing a lot in infrastructures in the area. So, for example, we have projects with, I can't say the name yet, but okay, one of the biggest heavy duty machines company. So they have already our machines. So they are producing this electricity to charge the heavy duty machines electrical. No? So will be the hydrogen in next step. So for the moment, they start with that. Also, even in the mining, these mines that you are having in these different countries. So why not? In the service stations, as I said, for example, all this supplying of electricity or hydrogen, it can be a solution like, okay, where we now having these diesel tanks, I can remove and I can put methanol there, and we are able to produce this electricity for the Teslas, electrical vehicles, or the hydrogen vehicles that we can have, no? Again, the same on the main important infrastructures in the maritime, in the airports, as I said, all the industry that at this moment are using hydrogen. If you compare these prices that I say you in the production, if you compare with the delivered hydrogen price, you see that you have a really good return of invest in that. No? So the numbers are helping us a lot. And another important point that I think is interesting in that question, we can say, is about the backup solution for different, of course, activities that we can have. No, for example, unfortunately at this moment, and maybe because you have borders near Russia, so it's like, okay, in this war or these army projects, that why not this decarbonization solution to can produce this electricity? For example, for the concerts, stadiums that they need maybe backups. Even for the electrolyzers, no? Even you have electrolyzers, I said, unfortunately, maybe they can work 24/7. And if you need this hydrogen, so we can be the backup of the electrolyzer. And well, we can adapt, of course, on that part. First of all, to reduce this maybe imported gas from Russia, or other solutions that can be so competitive in prices, like, for example, electricity or the hydrogen supplying.
Mm-hmm. Oh, Adrià, thank you so much. That was very detailed indeed. I really like the fact that you brought the grid problem within the Balkans regions. And even the blackouts in Spain that I still remember it from last year as well. The grid problem has always been there, and actually we have a lot of. It's actually a panel discussion in our 10th edition, but it's always been a topic in every single volcanic event as well. But of course, you have mentioned, return on investment, efficiency, of course, being the backup of electrolyzers and the Netherlands projects as well. So this makes sense how we can make it decentralized. Of course, you can support industrial decarbonization, as you said, in stadiums, and it doesn't have any kind of specific location. It can be Saudi Arabia, it can be Netherlands, can be everywhere as well, as long as if it works with a specific kind of a project or a case study. But let's say regarding technology, how does this technology integrate with carbon capture solutions and emerging carbon trading mechanisms? Of course, we have mentioned that it's the grid problem, the efficiency, the return on investment. It's we started with what we called, let's say, it's flexible, it's very effective, it works, but you need specific kind of things. And of course, it's we don't have it around the world. It's a pretty, let's say, low on production. But let's say in terms of technology, how can we integrate it with a carbon capture, and how can we merge it with carbon trading mechanisms?
Yeah, that's an important point too. No, at the end, it's like, of course, we are focused on that side. So it's the key, we can say. First of all, for us, it's I like to say that this is included or integrated with this carbon capture because one of the types of this green methanol is the e-methanol. No, so e-methanol is produced with carbon capture. So at the end, we start in this good mood, like okay, we are capturing this CO2, and we are using one use. No, that what I can do with this CO2. No, that sometimes is the question. It's not just about the capture of the CO2. Is what can I do with this CO2? So one of the solutions, for example, is then to produce e-methanol. No? So you can put the hydrogen with the carbon capture it, and after you can produce this methanol. Why? Because what I say, if you are producing methanol, for example, if you're producing hydrogen in I don't know now in Saudi Arabia, as we say, and I need to transport it to Europe, so methanol helps us, no, to can deliver it easy. I didn't say you before, but it's just to have to understand the sizes. Is with one truck or with one vessel of methanol is the same amount than 12 trucks of hydrogen compressed. So you can see that relation, no, between 1 to 12. So at the end, it's so useful to understand why I'm saying that it's good in the logistics. No? So the same in this carbon capture. So of course, we will have this carbon capture, but after that is, okay, what I can do with this carbon capture. So one of the useful things that we can do is use this e-methanol. And after this e-methanol, you can sell, or you can, well, do something to commercialize it, because it's at the end is one field that it will be used in some companies. No, so why I explain that is because we start, I think, that with that side, no, that we know our production, we start with this capture of the CO2 before, and after, of course, as I said, unfortunately, we can say we have CO2 in our production of hydrogen, one of the in a low measure, no, but we have this CO2. So we are working now, we are developing now a CO2 capture to include in our reformer. No, here the thing is that the space that we need. So we have already the CO2 capturer, but here the problem, or we can consider, is like the CO2 capturer is bigger than the reformer, so have no sense. No, so in terms of we want to develop some useful capturer that we can include and no increase the size. No, so but because if we can do that, of course we can say that we are total negative emissions of CO2 too. No, so at the end is one part of this solution. And at the end, returning to the question about this carbon trading mechanism too, no? So at the end is what is most important. But we can help in this EU ETS or CBAM because we produce, or we can produce with RFNBO certification, no? About these carbon credits that we can use, no? Or even, for example, I'm thinking now about Greece, no? That the all important maritime sector that you have there. So, for example, it can be a good solution, no? Because of course, maybe I will continue making this CO2, but if I say that I have some solutions related to e-methanol, so of course I can have these carbon credits, no? So all it helps in that solution that, okay, I'm producing maybe, I invent now, I'm producing now maybe in Montenegro, no, with my reformer, and maybe I don't produce in Greece, but okay, I can compensate these carbon credits, and I can say, look, I have these solutions that I decrease these emissions. I don't have these NOx and SOx. Of course, here will be the most important point in the certifications, no, and the regulations that we can have. But at the end, is a solution that I want to say is like a solution that will contribute, will help in this ETS and this alignment with the EU requirements on that carbon capture solutions. No.
Mm-hmm. No, correct, 100%, Adrià. I mean, I think, the fact that you said one methanol vessels is a markup of 12 hydrogen vessels, I think it sums up everything as well. This is quite wow. I think this is a great thing to know. But even, of course, methanol, we said it's easily transferred. Ammonia is kind of a poison, and methanol is kind of a safe thing to go for as well. But of course, it really depends on the case study, on the specific kind of project, on the country, and the depending on the pressure outcomes of the project as well. But I wanted to speak about, let's say, partnerships or market conditions, because you mentioned two different things. Of course, you mentioned that you applied this to the Netherlands and you applied this to Saudi Arabia. So it really depends about the market condition and the need, and even it depends on the partnership. What kind of partnership or market conditions are needed to accelerate the deployment across the Balkans and the wider EU region? Of course, we said it's easily transferred. It's let's say it's liquid based as well. But in terms, not only that, but in terms of regulations, in terms of sustainability, I do think, please let me know if I'm wrong, but I do think that methanol is the safest choice among, let's say, hydrogen or carbons. But please, feel free to elaborate on this, because EU has, of course, a lot of regulations, a lot of certificates. You need to be certified to be able to deploy this, and safety, etc. as well.
Yeah, always, as you said, sometimes the bureaucracy, doesn't help us in that kind of solutions, and that's always or can be a big problem, no? Because even in these countries, as I say, normally in the north of Europe, they are more active on that kind of solution. They started some years ago. So in the south, we need to start because we have a good conditions, no? As I said, so in the Balkans, for example, you have a good conditions to produce this methanol. So at the end, you can be total selfish. Sorry. So at the end, is a good solution for that. No, but what we need is more maybe understanding from the company, from the governments and from the regulations. No, because sometimes they can consider you a chemical plant and you say, okay, no, but for my capacity is nothing. No, if you compare with other solutions. So yes, here always is a good or is a big fight between the administration and the companies, no, or the projects. So permittings, even for the methanol, as I said, in the market there are a lot of experience in methanol, so it's a call and it's useful in a lot of industries. But sometimes when you have, for example, to put a tank of, I don't know now, maybe 50,000 liters of methanol, if you are I don't know now, in the middle of Tirana or Athens or something of these big cities, so can be a problem. So you need to manage that. No, so at the end, is needed to, of course, we respect all the safety regulations. We have the C certification. We have all the requirements, all the sensors too, because we know that one accident, not just for us, even for the hydrogen industry, it can be so damaged. No, so that's why we need this help from the administration sometimes. No, in some countries, they are really active. For example, in Poland or Germany, they are really active in that kind of solution. So what we need, first of all, is that these incentives, that can the companies to not just about the grants. I don't talking just about the grants or the funds or subsidies that we can have. Of course, is needed too sometimes because the technology we can say that is not cheap. It's a new technology, so always we can consider that is you have to pay a price. But most is in this kind of adapt, because at the end, I'm sorry, because it's not we can say it's not something wrong about the politics, but politics just like to talk not about the hydrogen and all, but when you arrive to the main purpose, it's like, okay, but you don't allow me to put this production point, no, and when it's sometimes needed, and you say that hydrogen will be the next fuel in Europe, no. So that's sometimes the important point. After that, of course, as I said, the good thing is that we are open to all kind of partnerships or relation with the market, with the area. As I said, I believe so much the same. I believe, for example, in the north, that the Balkans is a good place, for example, to start in this decarbonization, because at the end, you had, or I talk, sorry, because I talk always in general terms. I mean, it's not a country, but more dependence for the Russian gas. So at the end, you need more sustainable solutions for can change that. No, so we have a lot of challenges, and the grid, as I said, is a good point that to start. No, in that kind of solution that I can give this solution for all of these projects that we can include in our, we can say, portfolio, that we can be a solution for that. So these partnerships, we are open to of course, to all kind of projects. We, as I said, we like to discuss everything. So it's not about, no, it's just about our solution. No, we can integrate. Even we have projects to mix our solution with the solar panels, because, for example, some countries can, maybe in Greece or Spain or Bulgaria, you have a lot of sun, but maybe there are other countries that you don't have sun, maybe than in winter, for example, 3 or 4 hours, no? So why not? We can put the solar panels, and when we will need not sun, we can start with our reformer to produce this electricity, no? So at the end, the good thing is about these technologies is that, as I said, we can adapt and we can mix different solutions for one purpose, no? So at the end is this kind of production of this hydrogen or electricity. But yeah, so we need to collaborate, as I said at the beginning. No, mostly that it's not just okay, my solution is the best and the other no. So at the end is this kind of partnerships that we need in the market, but not just about our solution. For example, our company is the off-taker, the government. So I think that is we need more common policies and common regulations that to help to develop faster that, no, because it seems a stupid thing, but everybody talks about 2050. But if we don't start now, we will be late. So at the end is we need to consider these different solutions for that.
Correct. 100%, Adrià. I mean, of course, regarding methanol and kind of a mix and adapt and of course collaborate, it is a very important thing, especially for the Balkans region. Of course, there's a lot of sustainability issues going on, so we need to definitely look at other options. Of course, we have the grid problem, we have the Russian gas as well, so this is why we need to look at other options to just sustain and to have a kind of a plan B going on, of course, and to adapt to EU regulations. Before I close this webinar, I would like to ask the audience if they have any kind of questions. Please feel free to write them on the chat box, and of course, Adrià will get back to you with an answer regarding this amazing kind of a question. Adrià, thank you so much for your valuable insight today. I think from this clear discussion, I think I can say that the decarbonization in Southeast Europe will not be achieved through ambition alone. It requires solutions that are deployable, let's say commercially realistic, and aligned with industry structure of our region as well. Today's discussion is just the beginning. Of course, I look forward to continuing this conversation in person at the 10th Balkans Energy Summit in Athens. Of course, on behalf of IMVR, thank you so much for joining us here on the Methanol-Reformer team. Of course, Adrià will be joining us as a speaker for the panel about carbon capture and carbon trading. So for sure, we're going to have him again face-to-face in the event in May. So I look forward to seeing you there. And thank you so much once again for joining.
Thank you very much for the opportunity, Karam, again. So a pleasure to be here. And well, so happy if there is any questions or something like, so happy to answer it and to help it.
Great.
And thanks for the initiative too. So again, we need more initiative like this.
Great. Thank you so much, Adrià. And have a very nice day ahead. Thank you. Thank you so much.